Okay, this is our second video on this question from 2011, paper 2, time zone 2, calculus question. We had to graph the function, as you remember, and find the local minimum and maximum P1 and P2 on question 8. We used the calculator for that. Now I want to try and do some calculus. This is chapter 20. Okay, so we have the function we talked about before, that there's a vertical asymptote in the function. So again, remember, we're dividing by x here. We can't divide by 0. X cannot equal to 0, so that's where the vertical asymptote is, at x equals 0. Okay, so we wrote that answer down before. Okay, now let's talk about the derivative. How do you find the derivative of the function? Notice the notation is f prime of x. Okay, that's a prime up there. Okay, so we can use the formula booklet. In the formula booklet, that's what our question has. It has 3 terms. Okay, so we're going to find the derivative of that, and you can see that we have a formula for exponents here, the power rule, it's called. Okay, you take the n down front, you multiply it times the whole term, and then you take away 1 from the exponent when you're done. Okay, we can use this for single terms. We can use it for addition of terms. That's what this rule says down here, that if there's 2 terms, I can do it to 2 terms. Well, I can do it to 3 terms too, and that's question 5b. Finding the derivative. Okay, our function is f of x is equal to 1.5x plus a constant 4 plus 6 over x. Okay, we want to use the power rule, so we should find the exponents and use the exponents to find the derivative. Look at the first term. It doesn't look like there's an exponent here, but in fact there's an invisible 1. Okay, the exponent for the second term is actually, this is like x to the 0, or you could just say the derivative of a constant is 0. Finally, from chapter 19, we know that the exponent here is -1 because it's in the denominator. So rewrite the function using those exponents, and you get 1.5x to the first power, 4 times x to the 0 power if you want, and then 6 times x to the -1 power. Okay, now we're going to exercise the power rule to find the derivative. Derivative notation, f prime of x. Okay, I'm going to take the 1 down front, multiply it times the whole term, and then I'm going to take away 1 from the exponent to find the derivative. That's the power rule. So I got 1 times 1.5x to the 1 minus 1 if you want. Okay, and then second term, I'm going to take the 0 down front. 0 comes down front, multiply it times the term, take away 1 from the term. It doesn't really much matter from the exponent in that term. Doesn't really much matter because 0 times anything is going to be 0. This is going to be 0. Derivative of a constant is 0. And then finally, last term, -1 times 6x to the -2. Okay, you got to take away 1. Very important to take away 1 there. From -1, 1 from -1 is -2. Okay, use your calculator if you have troubles with negative numbers. Again, it's very important that you apply the power rule correctly. -1 times 6x to the -1 minus 1. Okay, f prime of x simplified. Again, 1 times anything is 1. X to the 0 is 1. That's just 1.5, the derivative of the first term. Derivative of the second term was 0. And then the last term is a negative 6x to the minus 2. If you don't like the negative exponents, write it without negative exponents. F prime of x equals 1.5 minus 6 over x squared. There's our answer for part B. Okay, part C asks us to find the gradient at x is equal to negative 1. So in fact, it's asking for f prime of negative 1. So you just have to put in at negative 1 into your derivative function. Again, the first term was constant, 1.5. Second term is 6 over x squared, so I'm just going to do 6 over negative 1 squared. Notice that I got the negative number in brackets. Very important. Okay, so that derivative is equal to 1.5 minus 6 over 1. I'm just going to say 6. And the slope is negative 4.5. Part D is going to ask us, what does that gradient mean? Does it mean that the function is increasing or decreasing? This is a negative rate of change. So that means that the function is decreasing because the gradient is negative. I don't know how you want to say that, as you wish. You can use it in words or write an inequality or say the derivative is less than 0. All those answers are acceptable for the examiner.